The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So problem 7 states the density of oil is 0.8 grams per centimeter cubed and the height h of the column of oil shown is blank. So we're going to be solving for h. I give you a picture. So this is our oil. H. And our water all the way down here up to this point, and this distance is equal to 2 centimeters. So whenever you have a problem such as this, what you have to do is you realize that the diameter of this doesn't matter. So as long as it's in a constant tube, then you're fine with the diameters. And you just realize that the pressures at the point must be equal if it's in static equilibrium, which it is. And generally all the problems you do in this class, most of them are in a static equilibrium, except for the Bernoulli ones, of course. But anyway, so whenever you have one of these, figure out what the book calls the interface, the point at which everything below a certain line is the same fluid. We know that the weight of the water over here pushes down, the weight of the water over here pushes down, and they equal out, because it's the same height of water. The only thing that matters with fluids, concerning pressures and weights, is the height. So if everything here on below this line is balanced, then what we know is that this part of the water right here and this part of the oil have to have the same pressure at this location. Okay? So formula for pressure is going to be equal to rho GH. That's how you calculate the pressure at any points. Generally it's written with a P naught, but we know that P naught at both of these points is just the pressure of the atmosphere, and it's going to be the same, so it's going to end up canceling out, and we're not concerned about that. As long as they're both open-ended, you don't ever have to worry about the P naught when you're doing one of these problems, because they end up canceling. The weight of the atmosphere affects both of these equally. Okay? What we're concerned about is these two. So, if they're equal to each other, we know the pressure vector here and the pressure vector here, this one due to the water and this one due to the oil, are going to be exactly the same. Don't confuse, that's not P naught, that's P oil. Okay? From there, we can say that the density of oil times gravity times the height of the oil must be equal to the density of the water times gravity times the height of the water. Okay? So we know the density of oil they gave us as 0.8. We know, I'm just going to leave gravity because it cancels out. It's on both sides of the equation. And the height of the oil is expressed as h in the problem. Density of water, now density of oil was given as 0.8 grams per centimeter cubed. So I'm going to give the density of water in grams per centimeter cubed. Either give them both in kilograms per meter cubed or give them both in grams per centimeter cubed. Just be consistent with your units. So that the density of water is just 1 gram per centimeter cubed. And the height of the water, be careful with this. A lot of times they'll purposely give you a number that's not the correct answer. This isn't the height above the line. This is the height above the line that we're looking for. We don't know what the value is because we don't know what h is, but we can express it in terms of h as, over here, h minus 2. This h minus this 2 gives you that vector, that height. So, plug that in for the h of water, remembering that we dropped out our gravity component. And so what we can say is that 0.8 h is equal to h minus 2. So, subtract 0.8 from 1, and you get 0.2 h equals, bring the 2 over here, 2. And h is just going to be equal to 10. And our units, remember our densities were both expressed in grams per centimeter cubed, and they were on both sides of the equation, so they cancel out. We use 2 is in centimeters, so this answer must be in centimeters as well. I know they constantly, and myself as well, to anybody I'm trying to help, tells you to use units, meters, kilograms, and seconds. As long as you're consistent with units and all the units are in this, all the units in the equation are the same units, then it's fine. That is really only recommended when you have the same side of the equation. If you have like an F equals MA, then make sure you use the standard units. But if you have this is equal to this, just keep the units the same, you should be fine. So, keynotes in this problem, find the interface, where everything below that level is the same fluid. Once you find that, nothing below that line matters. The only thing that matters is above the line. Make sure you use the right value for your heights that they give you. The h minus 2 is important, not the 2. 2 would give you the wrong answer, and I'm fairly certain that they gave you an answer assuming you use this as a trick answer to try to trick you into using it. And yeah, that's the end of the problem.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.